we move the next exercise. Now we will see how to solve the given system of equation by matrix inversion method. The next exercise, we use the given system of equations solved by another rule. This is called a Graham's rule. Same, there will be two equations or three equations are given. Solve the equation by a Graham's rule. It has also a formula and also it is very easy one. The given system of equation is given. Using this Graham's rule to solve. I given an easy example. 2x minus 3y is equal to 0. Suppose I will take one two variable equation and 4x plus 3y is equal to suppose minus 1. Now our question is to solve these two equations by using a Graham's rule. It has some formula. Using the formula to solve. The formula is using this Graham's rule. First I tell the formula, then how to find the terms. Using this Graham's rule, it is a formula of x, del x by del. The value of y is del y by del. Suppose three equations and three unknowns is given. It is a formula to calculate z. Z is equal to del z by del. We should read it as del x, but we put the x in suffix in small letter del x. Okay, the next step, how to calculate this delta, or we should shortcut for del. How to find del x, del y, or we should be read it as delta x, delta y and delta z. So we pronounce just del. How to find del x and del y? It's an easy one. The value of del is determinant. So this method is called a Graham's rule, or in another way we say it is a determinant rule. Using del x, del y all are involving determinant. The value of del is nothing but coefficient of x and y in the first equation lies in first row. Coefficient of x and y in second equation lies in second row. So suppose this question will be x. What is the coefficient of x and y in the first equation? 2 minus 3. It lies in first row. 2 minus 3. And coefficient of x and y in the second equation is 4, 3. It lies in second row. So in each and every sum, it is the value of a del. Del means coefficient of x and y determinants. First equation coefficient of x and y lies in first row. Second equation coefficient of x and y lies in second row. Next we find the value of this determinant. You know very well how to find. Okay, next. How to find del x? Is also determinant. All values is involving determinant. To find del x, you see the variable is x. So in del x, we leave the coefficient of x column. You know it is a coefficient of x in both the equations. We leave or we eliminate coefficient of x column. We enter the RHS value. It is called del x. What is the RHS value in the equation? 0 minus 1. So we leave coefficient of x column and we enter the RHS value is called del x. So the RHS value is 0 minus 1. We leave the coefficient of x column, we enter the RHS. And the second column we write as it is, minus 3 plus 3. So it is a value of del x. So del x means in del, we leave the coefficient of x column and we enter the RHS value. So the next column is no change. Del y. So del y is there. So we leave the coefficient of y column in del. So it is a value of del. In del, we leave the coefficient of y column and we enter the RHS value. So the first column is no change. 2, 4. You see in del, we leave the coefficient of y column. Minus 3 plus 3 is there. We leave. Instead of minus 3 and plus 3, we enter the RHS of the given equation. RHS of the given equation 0 minus 1. 0 minus 1. So it is a working rule to find del x and del y. Now we will take two equations. Suppose three equations, three unknowns is given using the same way. Del is nothing but coefficient of x, y, z. Suppose three equations is given x, y, z in first row, second row, third row. The first equation coefficient of x and y, z is lies in the first row. Second equation is lies in second row. Third equation lies in third row. Del x means we remove the coefficient of x column, we enter the RHS column. Del y means we remove the coefficient of y column, we enter the RHS column. The same manner z also. Suppose del z we find, we remove the coefficient of z column, we enter the RHS, it is a value of del z. And finally, the formula to calculate x, y and z is this one. The formula of x is del x by del. That is, the denominator is the value of del x and denominator is the value of del y. Denominator is del y and denominator is del. Suppose three equations is given, three unknowns is given. The formula to calculate z is del z by del. Now using this Cramer's rule to solve some problems. See in exercise 1.4, the first one. You see the question, solve the following system of linear equations. You know already tell what is meant by system. 1, 2 or 3 equations. Mingle of all equations is called a system. Of a linear equations, coefficient of x and y should come, and also there is no square term involved, it is called a linear. So two equations is given. Now to solve these two equations by, you see the question is a Cramer's rule. So in Cramer's rule, two equations, two unknowns is given. So we find x and y. You remember the formula? The formula to calculate x in Cramer's rule is del x by del. The formula of y is del y by del. So to find del x, del y. The first one important. In given equations, we keep the coefficient of x and y only lies in LHS and we keep the constant in RHS. So given equations, I modify 5x minus 2y. You see the constant is also lies in LHS. So you don't confuse. The constant is suppose goes to RHS, it become minus 16. Plus 16 becomes that side minus 16. The second equation also, x plus 3y, constant term is also lies in LHS. It goes in RHS, it become plus 7, x plus 3y is equal to plus 7. So first, for our convenience, we keep the coefficient of x and y term only in LHS and the constant term lies in RHS. After finding these two equations, the next step to find the value of del. Important, all are determinants. Because determinant only have a value, the matrix cannot have a value. Del is equal to determinant of coefficient of x and y lies in first row of the first equation. What is the coefficient of x, y in first equation? 5 minus 2. 5 minus 2. It lies in first row. Coefficient of x, y in the second equation is 1, 3. 1, 3. Now we find the value of this determinant, it is a value of del. How to calculate? You know very well. First we multiply the leading diagonal elements. 5 3s are 15. Next we multiply these two elements with a minus 1. So minus and minus is plus. So plus 2. So the value of del is 15 plus 2. The value of del is 17. So first step to find the value of del. The next step to find the value of del x. What is the working rule to find del x? We find del x. So we remove the coefficient of x column in del. We enter, instead of 5, 1, we enter the RHS minus 16, 7. So we leave the coefficient of x column and we enter the RHS column. RHS column minus 16, 7. So it lies in the first column. Minus 16, 7. And the second column is no change. We write as it is. What is the second column of del? Minus 2, 3. Now we multiply this. Minus 16 into 3 is a minus 48. Okay, minus 48. Then we multiply these two elements with a minus sign. So minus and minus is plus 14. Okay. So the value of del x is minus 48 plus 14. The big number is minus, so minus. 8 minus 4 is 4. 4 minus 1 is 3. So the value of del x is minus 34. After finding del x, next we find del y. What is the working rule to find del y? In del, we remove the coefficient of y column, we enter the RHS value. So now we come in del, the value of del 5, 1, minus 2, 3. Now we find del y. So coefficient of x column is no change. So we write the coefficient of x column as it is 5, 1. 5, 1. And we remove the coefficient of y column. Okay, it is a coefficient of y column because minus 2 is a coefficient of y in the first equation. Plus 3 is a coefficient of y in the second equation. We leave the coefficient of y column. We enter this RHS value. So RHS value is a minus 16, 7. So minus 16, 7. 5, 7. 5, 7, sir. 35. 1 minus is already there. Minus and minus is plus. 116, sir. 16. So the value of del y is 35 plus 16 is 51. Now we find the required terms. That is, we find del x, del y. Next, we write the formula of x and del x. The formula to calculate x in Graham's rule is del x by del. The formula to calculate y in Graham's rule is del y by del. What is the value of del x? The value of del x is a minus 34 by the value of del is 17. Minus 34 by 17. So x value is a minus 2 and y value is del y by del. The value of del y is 51 divided by the value of del is 17. So 51 by 17. So the value of y is in 17th table exactly 3 times is the value of 51. Therefore, the solution of the given sum is x is equal to minus 2 and y is equal to 3. We already tell how to verify. Suppose our given answer is correct or wrong. How to check? We replace the value of x and y in either one equation. Suppose the equation is satisfied, our answer is correct. If substitute, it may be the first equation or the second equation. Using this same Graham's rule, we solve the second one. But you see, in second subdivision, the variable y, no problem, it lies in numerator. But you see the variable x lies in denominator. The Graham's rule is applicable only when all the variable lies in numerator. Suppose it lies in denominator, we convert first of all. So first, I will take this 1 by x is your choice. You will be taking any letter except xn. So I will be taking this capital X. Or I will take this z also, is your choice. So I will take this capital X. So how to change the first equation? 3 by x. If we take 1 by x is capital X. So we write it is 3 of 1 by x. So 3 of 1 by x is nothing but 3x. So 3 capital X. No change the second variable. 2 1 is equal to 12. Already the constant lies in RHS. Second equation. How to change 2 by x? It become 2 capital letter X. We take 1 by x is capital X or 2x plus 3y is equal to 30. So Graham's rule is applicable only when the variables lies in numerator. Suppose if it is denominator, to convert another variable. So now we take it is capital X. The next step to find the value of a del. Same rule. The formula to calculate del is using determinant. The first row is the coefficient of x and y in the first equation. Important is the coefficient of capital X. 3, 2. 3, 2. And the second equation coefficient of capital X and y is 2, 3. Now we find that value. 2, 3. Now we find the value. 3, 3 is 9 minus 4. Minus 2 is 4. So the value of a del is 9 minus 5 is 9 minus 4 is 5. So we find the value of a del. Next, to find the value of del x. Del is a small letter x or capital X. Important is a capital X because the coefficient is capital X. So next, del capital letter X. So whose values is entered by in del, we remove the coefficient of capital X column. Okay, we find del x. So in del, we remove the coefficient of capital X column and we enter the RHS value. So we remove this column, we enter this RHS value 12, 13. It lies in first column 12, 13. And the second column is no change because we find del x. So second column is a 2, 3. 12, 3 is a 36. Both the plus, so put minus. 32 is 26. So the value of del capital X is 10. So del x is over. Next we find del y. Y there is no change. You see the coefficient of y are smaller. So del y. Same rule. Del y means in del we remove the coefficient of y column, we enter the RHS value. So in del y, in del the coefficient of x column is no change. So 3, 2 is no change. So 3, 2. And we remove the coefficient of y column. We remove this column. We enter the RHS value. The RHS value is 12, 13. 3 37 is 39. Both are plus symbol, so minus. We multiply one minus n, so I put minus. 2 12s are 24. So the value of del y is equal to 39 minus 24. 9 minus 4 is 5. 3 minus 2 is 1. Is 15. Next, we write the formula of x and y. Is a small letter x or capital X. We find the value of capital letter x and y only. So next we write the formula of capital letter x, whose formula is del capital letter x by del. Next y, but y is small letter. The formula of y is del y by del. Now we enter the values. The value of del x is 10 by the value of del. The value of del is, the value of this del is 5. So we use the value here 5. Next y, del y by del. The value of del y is 15. The value of del y is 15 divided by del. The value of del is 5. We cancel, we get 2. And we cancel in a fifth table, it is 3. So y value is 3. And capital letter x value is 2. It is our required solution? It is not our required solution because our given sum contains a small letter x and y. For our convenience, we find capital X. The next step to change. Okay, but small letter x, 1 by x is nothing but capital letter X. That is 1 by x is equal to capital X. The value is 2. We need only small letter x. What is the next step? Taking reciprocal. So taking reciprocal on both sides, we get the value of x is 1 by 2. Therefore, the value of x is half and the value of y is equal to 3. It is our required solution. The value of x is 1 by 2 and the value of y is equal to 3. I verify this equation. So verification is no need. Check our answer. So if we take any one of the given equation, it may be the first equation or second equation, is your choice. I will take the second equation. What is the second equation? 2 by x plus 3y is equal to 30. Now we substitute the value of x and y. It satisfies this equation. That is, the LHS is exactly will come 30. We check 2 by x. The value of x is 1 by 2 plus 3 y. The value of y is 3. 30. Now this 2 goes to numerator. Denominator is a fraction, so this 2 goes to numerator. 2 to 4 plus 3 3 is 9 is equal to 13. So 13 is equal to 13. So our answer is correct. Okay students, today first we say one practical problem, that is a matrix inversion method. So word problem is that first to convert the given word problem in an equation and then to solve in matrix equation method. Next we go move the next exercise, that is a Grammar's rule. How to calculate del x del y. Now we see two equations, two unknowns. In the next class we see three equations and three unknowns. In Grammar's rule, the formula to calculate x is del x by del. The formula of y is del y by del. How to calculate del x del y? All are involving determinants. Del, the coefficient of x and y lies in the first row. Coefficient of x and y in the second equation lies in the second row. In del x, we remove the coefficient of x column, we enter the RHS values. Is the value of del x. Y, the formula to calculate y is del y by del. And how to calculate del y? The formula of del y is in del. We remove the coefficient of y column and we enter the RHS value. The same model sum lies in example also. We must try.